John, we've been asked to do a film about phosphates.
Phosphates? Where do we start with that?
So this is where the story starts.
In 2022, local authorities in Somerset received a letter from Natural England about the high level of phosphates in the Somerset Levels and moors. Councils are now unable to approve any planning application that may give rise to additional phosphates. This applies to an area that extends well beyond the levels and covers a large part of Somerset. There's now an unprecedented backlog of planning applications in the pipeline. The situation is far from resolved. We set out to find out more about the problem. But first of all, we had to know, what are phosphates? So we asked a friend of mine, scientist Dr. Len Fisher, and a professor of biogeochemistry, Penny Johns, to explain.
Phosphorus is an element, yellow waxy stuff, that burns. But the thing that plants and animals use are phosphates. That's when you combine phosphorus with oxygen and other things. So it makes nice long chains, and it's now a molecule.
So phosphorus is very rare in the environment, but it's essential for life. If you haven't got it, you can't make DNA. It forms a sugar phosphate backbone that sticks the DNA helix together. So without it, you can't make life. And there are lots of different forms of phosphorus in the environment, and the one that most people have heard of is phosphate.
Well, I think somebody was waving around this great cycle. These things never make much sense to me, but basically phosphates are formed in the ground, rocks, weathers, comes down, gradually flows through the ground and leaches out into the water in due course. That's a very slow process.
But obviously if we have more, if we're adding it to the land surface as a fertiliser, if we're adding it to animal feeds, if we are consuming it in our diets and we're excreting it, it's going to sewage works and that's washing into a watercourse, that additional phosphorus will allow more life to thrive, and so we get increases in productivity.
The thing that we're worrying about is where plants take up phosphorus, where we put phosphorus on phosphates, I should say, on farms, and it all washes off, and that's a much faster process. That's what's shoving phosphates into the rivers, into the streams, eventually into the ocean.
So that will be coming from septic tanks, it will be coming from sewage treatment works, small ones, large ones as well. It may be coming from industrial discharges, depending on the nature of the landscape, and then it will be coming from agriculture, because we add phosphorus in order to produce food.
The problem is that it's a food for other things beside the plants that we're trying to feed and grow. And especially it is food for algae, these very microscopic organisms.
So I'm here on the Somerset Levels, standing in a reen with my camera to see what's going on below the water. As you can see, there's quite a lot of algae bloom on the surface level. So it's going to be interesting to see what's going on down below. Across Britain, all of our waterways are being slowly polluted by sewage, oil, and the result of this use of phosphates. And it is, as you can see, it is having an impact on the natural environment. And especially as a young person, I dread to kind of think what it's going to be like in 10 years, 20 years if we don't do something about it.
When phosphate, excess phosphate, washes off the land into the rivers, it becomes a food for they're called cyanobacteria. You can call them blue-green algae. What they are is those great green mats that form, and they're forming just because they got the food available, just phosphate. But that's now creating shade and lack of light down lower, which means the plants that usually produce oxygen bubbling up from below no longer can so efficiently. It gets worse than that because the algal mats will eventually die. bacteria will start to eat them. And the whole gooey mess with all the phosphate in it gradually sinks to the bottom, taking the phosphate away until it gets released in a burst sometime later to form even more algal mats. And also, the bacteria that eat them are releasing things like methane, carbon dioxide, greenhouse gases, being pumped up into the atmosphere.
Is the phosphate then lost? Is that it?
It depends very much on the waterway. It's not, but there's a timescale involved. In somewhere like the Somerset Levels, where you've got things sitting very steady and where basically the only way that you can get the stuff from the bottom is out by hand, sort of shovelful by shovelful, then you've got a much longer timescale. It's just going to sit there, but it's still there, and at some stage it's going to come back.
Ray, why is the phosphate problem such an issue on the Somerset Levels?
Well, because the land's flat, because it settles, as this floodwater comes in and it carries all the nutrients with it and it settles on the ground. It's very flat. There's only 6 inches in the mile 4 from here to the sea, so when it runs off very slowly, the silt having settled out and all the nutrients with it.
Right.
And it's what, I mean, they used to encourage it to flood just for that reason. They used to dig trenches in the banks and let the water come out in the winter because it was really good grazing ground then. The grass was lush in the spring and summer after the floods had gone. But of course the farms up on the hills have got bigger, the population's grown, the water treatment works have got bigger, so there's more and more nutrients coming down, and now the rivers are bad. It's coming over here all the time. I mean, you can't see the state the riverbed's in now because it's full, but these trees are where pieces of log have floated down the river and settled in the silt and they've grown into trees. These were all cleaned out twice a year.
Really?
Yes.
How often do they ever do it now?
No.
Not at all?
Just cut the weeds.
And you can see, can't you, from the banks, all these nettles, which is a sign of pollution of nitrogen, phosphate, all the rest of it.
It stimulates plant growth, and it could be what we call macrophytes, which are large plants, or it could be algal growth, so it could be free-floating algae which form algal blooms, or it could be filamentous algae like we see in the moat in Wells. All of those will be using that phosphorus along with nitrogen, carbon, hydrogen and oxygen to produce more biomass. And the problem is it overstimulates that, and then when the biomass breaks down, it then stimulates microbial activity, and the microbes consume oxygen, and you can end up with a drop in the oxygen concentration in the water body. And in the most extreme examples, that can drop low enough to actually kill the fish.
What's going on in front of us here?
Well, this is wheat that was planted about a month ago following a crop of maize as part of the rotation we do. This moor is particularly good at growing maize. I mean, the maize in the photograph is about 12 feet high. It's a phenomenal crop, and it's virtually guaranteed every year, and it'll benefit this year because it's flooded. We got more nutrients, but we feed it. When we put the seed in, we put just the right nutrients in to keep that crop through to the autumn. And the stuff that grows around the riverbank, we desilt these ditches. The stuff that grows in that silt afterwards is always much greener and much taller, where there is a surplus of nutrients.
These are all organic stores. So they're store cattle. They've come from a suckler farm on the top of Exmoor when they're about a year old, and they've been on this farm for just under a year, so they're being grown for beef.
You don't have to add extra things to the ground.
No, we don't have to add synthetic bagged fertiliser, which is where a lot of people would get their phosphate. So yeah, we can't just sprinkle it on.
Great.
So everything that comes out of these cattle, we want it to stay in the soil.
Goes back in there.
Yeah, that's the aim of the game. You've got to think of it as a kind of a cycle, so we're trying to hang on to it.
Now, where we're talking about agricultural sources, they're what we call diffuse. So they are going to be they're oozing out of the landscape most of the time, and when you get a storm event, you get flushing of material either over the surface of the land or through the soil. So what we need to do there is we need to work with farmers to find better ways of farming where we can balance the tonnage of nutrients coming in at the farm gate, nitrogen and phosphorus, against the tonnage of nitrogen and phosphorus coming out in crops and in feed and other foodstuffs, so that we don't have a surplus that runs off the farm and into the nearest ditch. Now, there's a number of ways that you can do that, and organic farmers are going to approach that differently than those using inorganic fertilisers, but both of them need to find a way where we're actually limiting the amount of the material that's leaving the land and working its way into the watercourse.
With the best will in the world, there's bound to be some level of leaching from the best organic, most wonderful farm in the world. There's still going to be phosphate loss either through leaching or definitely through that animal or that crop leaving the farm gate. So we're still very much in it, but we are kind of aware of it and trying to do something. A big part of that is we monitor the different fields' nutrient levels. So we're trying to see where there's already lots of different nutrients.
Yeah.
But for us, particularly phosphate, that's the one which we are lowest in certain areas. But other fields are very high in that. So we try to manage our manure and slurry spreading to try and keep those nutrients where they're needed.
So it's not a question of organic good and inorganic bad. It's a question of balancing the books in terms of the amount that's coming into the farm and the amount that's coming off. And if you get that right, you can actually drive down costs for farmers.
So this shed is to stop the rainwater going into our muck store here, and then the nutrients stay in the pit and then can be spread when the grass actually needs it.
Well, what your farmer's done is really clever. Of course, rain washing the stuff into the rivers is one of your big problems, and the more you can keep your original materials dry, the better it is. You can also, for example, build barriers next to the rivers, next to the streams and so on, to stop the runoff. There's multiple things that you can do. I mean, we really need to do all of them. But that business of keeping things dry, just making the investment, I think is a really good way to start.
A team from Bath University has developed a bacterial variant that can mop up phosphate from wastewater and release it into the soil. There are compost toilets, and combining magnesium with urine can produce crystals to be used as a fertiliser. So there's no shortage of ideas and possible solutions.
So we've been trying to legislate and to control phosphorus pollution in watercourses for a long time. We now have the new Environment Act with quite significant reductions of both nitrogen and phosphorus required in our water bodies. We're looking at 40% reduction in nitrogen and 50% reduction of phosphorus loading. And that's going to require significant reductions not just from sewage treatment systems, but also from septic tanks, from rural sewage works, and from agriculture. One of the things that's happening more recently is the idea that if you have a sewage works which already has 10,000 people attached to it, it may not have the capacity to handle more sewage and achieve the same level of phosphorus target in terms of the effluent quality. And traditionally, we have allowed development to take place without taking this into account. Now what we're trying to do is say, you can't build more houses if we don't have the sewage treatment capacity to remove that amount of phosphorus. So the pitch is shifting, if you like.
The village really needs some houses. It needs to grow a bit to get some facilities here. And I've retired, got rid of the animals a year ago now, and we looked into, before we got rid of the animals, looking into converting this now for houses, because it's too close to the village to be an effective livestock farm. We don't want the smell and the noise and the early morning starts this close to the village.
Yeah.
So we did all the tests, the soil tests and everything needed, and then ran up against this phosphate thing, which is dead in its tracks then.
What is the actual problem then, that you can't build them because of the...
Well, because of the extra phosphates that will be put in by the 9 houses, and the phosphates going out in the moorland. They've stopped all building in virtually most of Somerset because of this, and they've got to come up with some solution to it. But when you look at, there was 450 bovine animals here, and surely they're putting out more phosphates than 9 houses would, but they don't take that into consideration. We went to someone to come up with some sort of solution, and they said we'd need to plant about 30 odd acres of trees and look after them for 20 years. Being a farmer, I don't like to take good land that's producing food out of production for trees. I mean, there's plenty of poor ground that could happen on. It's down to the water companies really, but I don't think they'll spend the money on the small sewage works in our village. We got enough big houses. Most of the houses built in this village in the last few years have been like 400, 500,000. The salaries that around here are so low in agriculture, in all the other horticulture industries, and they can't afford £500,000 houses.
No, they certainly can't.
And it's so all the people that have been born and bred in the village are having to move out. And we found that, and I was just hoping that we could perhaps address that.
But there are questions about, with new developments, for example, whether we should be looking at closed systems where the householder has to pay for the tank to be pumped out and taken to a larger sewage works which has the capacity to remove and recycle more materials. And so many water companies are talking about water recycling centres rather than waste treatment plants. So they're seeing this as a resource for recycling and moving towards what we call a circular economy, where we have more recycling, it's more sustainable, it's less environmentally damaging.
We went to meet Andy Mears at Wessex Water's treatment works in Wincanton. We asked him to talk us through the process of dealing with raw sewage.
They use a combination of gravity, naturally occurring bacteria and oxygen to treat the incoming sewage. There's several processes that it goes through, and the results are a treated effluent that can go to the river. It looks clear, it doesn't smell, and the EA will give us a licence for making that discharge. We also produce a treated sewage sludge that can go back to land as a fertiliser, and methane gas, which can be burnt and used as a fuel, as a biogas. So that's the basic traditional sewage treatment technique. It's a very traditional process. Most sewage works in Britain are. They don't take out phosphorus. Here we have a phosphorus removal plant as well, and we're putting more and more in around the region, and by 2025 we're going to be up to about 140 plants, and 50 of those can affect the Somerset Levels. They're linked with the rivers Parrett and Tone. There's a lot of infrastructure behind that. We dose the ferric sulfate into the treated sewage at one of its settlement stages, and it acts as a coagulant, so even more solids are settled out and the phosphorus is taken out that way. So that phosphorus ends up in the sludge, which is treated and goes to land. So it's a nice cycle.
Yeah, because the nitrogen and phosphate content of all the stuff is a really valuable resource, isn't
Absolutely.
it? Well, Andy, this is looking pretty gruesome.
Yeah.
What's going on in this bit?
Well, this is a primary settlement tank, so the sewage has just come in here and we're going to settle out solids. We're going to slow it all down and let the crude sludge settle out, really nasty sludge. And then what comes off the top of the tanks here, that's the effluent that goes on for biological treatment, make it ready to go out to the river. A long way to go yet, this is early days in the treatment stage. Well, John, this is the biological treatment. This is the really clever bit. These beds are about 2 metres deep and they're full of stones and rocks with a very big surface area. A biological community builds up on there, all sorts of things. Bacteria, leeches, bugs, fly larvae. And they actually treat the sewage as it goes through, as it trickles through. They need oxygen, so it's important that there's gaps for oxygen to get through. It's important that the sewage effluent is distributed evenly, and that's what these arms are achieving here. And by the time it comes out of the bottom, a lot of the biological load has been taken out and it can go on for a final treatment stage.
Wessex Water are lucky to have people like Andrew. His commitment and knowledge was impressive. But government inaction and the incessant need to satisfy shareholders' dividends distorts the effectiveness of this formerly publicly owned service. We know there are real problems with sewage getting into our rivers and seas. Is this just down to politics and profits, or is there more we can do?
There are several ways to solve it. One is to separate it at source. So that's getting alongside homeowners and encouraging homeowners to take out their rainwater and get it into a soakaway. That's difficult because you've got thousands and thousands and thousands of properties to do, so it takes a long time, and people like quick solutions. But we are doing that. We've started pilots now in the Wessex water area.
All of which is well and good, but what about the storm drains and the daily deposits of sewage dumped in our rivers and seas?
Our planners have calculated that about 180 storm overflows in Wessex Waters region will need to be improved between 2025 and 2030. That's hydraulic improvements to stop them spilling or to treat the flows. We've never done anything like that before. It is unprecedented, and it will cost a lot of money, but I'll vote for it.
I've heard that cheaper bacon seems to be injected with phosphate. Is this true?
Yep, my mother used to order a pumped ham for Christmas, and that's a ham that's had polyphosphates, just long chains of them, added. And the reason why they were added, because they then are able to hold more water. The phosphate attracts and soaks up the water, and of course water's cheap. The ham is heavier. She thought she was getting more ham. What she was getting was more water. And you get the same sort of thing with bacon. The way to tell with bacon, incidentally, just stick a rasher under the grill. If it starts fizzing and bubbling and giving you those nasty little greasy bits, that's got phosphate in it.
Ah, thank you. Perhaps it's too easy to see this problem as being someone else's fault, whether it's government, water companies or industry. At Coyne's Vineyard, Alan Chubb lets nature lead the way.
If you look on the ground, we've got a mixture of grasses, of the herbs and the clovers, and they all put nutrient back into the soil. All the prunings that we take from what you can see here, we'll be chopping off and putting back into the soil with I've got a flail mower which chops it all up so it rots all the way back down into the soil.
So it kind of completes the cycle.
So as the only thing we take out of here over the 22 years we've been going has been grapes, and the only thing we put in is some seaweed mix and a liquid tea that I make from comfrey. Over here we have a plant of Russian comfrey. It's been got away from the big plot that we have. So we just take loads and loads of that, shove it in the barrel, and then after about 2 or 3 weeks we get this lovely fertiliser coming out the bottom. Now if you'd like to drink that, John. So
I'd rather not, actually.
Now this is a liquid which is full of natural microflora, we'd call it, all sorts of bacteria and fungi, and it's rich in nitrogen, phosphorus and potassium, and the notable word phosphorus comes out. And we take this and we spray it in the vineyard. The only thing I've been adding is seaweed and my comfrey mix over 22 years. And my yields are the same as conventional vineyards.
Much of the pollution suffered on the Somerset Levels does not emanate from the communities and business within the levels, but from those located in the surrounding hills. At Wyke Farm near Bruton, the Clothier family minimise their impact and take their responsibilities seriously. They offer a solution for dairy farmers everywhere. Richard, this is an extraordinary thing in the middle of the Somerset countryside. What have we got here?
So this is our biogas plant. So this is a plant where we take in all of our organic waste from our cheese making, from the farms and local farms. We even take in apple pumice, bread waste, and anything that's not wanted anymore and is organic matter. We can digest it through these digesters using these very clever methanogenic bacteria which basically gobble up the solids and produce loads of methane. And what they do is they take out all the organic matter, produce loads of methane for our energy, which we use to generate all of our electrical energy for our cheese making. But we also upgrade the gas, clean it up, put an odour into it and inject it back into the grid. So all from organic waste streams. You can see there a load of farm slurry just arriving. It goes into this reception area here. To most people, it just looks like slurry, waste and something horrible. But for us, it's nature's crude oil, because this is highly calorific, and that's what's going to generate loads of gas for us, and at the end of the day it'll become a really nice fertiliser for use on the farm. So this is bread waste. You know, the sad story about bread is that something like 50% of the bread in the UK is never eaten, and it's wasted. And this bread waste comes out of supermarkets and everything in the local area. And we're a bit like a sort of a scrapyard, really, that will buy in any organic waste that people don't want.
This looks a bit strawy over there.
Yeah, so that's the chopped straw pile there. So we can chop rape straw or wheat straw or anything like that, and that's quite calorifically dense. It's quite good in the plant as well, because it gives the bacteria something to flocculate around. So they're quite nice solids. So the gas comes out of the lids. It comes through a pipeline. This is one of the generators here. This generator is housed in an acoustic box so that you can't hear the noise. I mean, it's pretty quiet here, considering you've got a really big engine in there, which is running on biomethane, and it's producing 500 kilowatts an hour of energy. It doesn't stop. We don't want it to stop. If it stops, it's not a planned thing. So the livestock intensive areas of the country have lots and lots of phosphates. The arable plains such as Salisbury Plain and East Anglia are very, very short of phosphates. So what we're trying to do here is harvest the phosphates from the southwest, and then take those phosphates back up onto Salisbury Plain, where they're very, very valuable for farmers, and reduce the farmers' carbon footprints and costs quite markedly. There are all different size versions of biogas plants, and so the whole project is scalable. I think it's the right thing to do for farms to have organic waste going through digesters like this to take out the methane and improve the environmental impact and free up the organic fertiliser. But the challenge is that hardly any organic waste off of farms in the country is going through biogas. And if you put a biogas plant on an average dairy farm, just by the treatment of the manure, it can lower the carbon footprint by about 33%. So if you can cut the carbon footprint of dairy farms in the UK by a third, without including the energy benefits and the benefits of slurry control and all the other stuff, then it's a fantastic win for the whole of farming for the UK. And I'm frustrated that no one in government seems to be that engaged with it and see it as part of a long-term solution for energy and climate challenges.
When we don't have people in power and listening to us, actually taking action on these things, it makes it pretty hard. There's a huge link between young people having, poor mental health and also knowing a lot about the climate crisis now. A way that I've dealt with, worrying about climate change and eco-anxiety, if you want to call it that, is doing climate activism and, meeting other young people. But at the same time, I don't think it should have to be the responsibility of young people to kind of spend their school years, their university years fighting for climate justice.
When we started making this film, we heard about a very unusual protest. A sculpture of the Virgin Mary was carried on 2 canoes 75 miles down the River Wye. Blessings were held in churches, bells were rung, and there was a choral evensong in Hereford Cathedral. The government, however, has refused plans for protection of the river, arguing that this would add another tier of regulation.
So everyone's got a part to play in trying to solve the phosphorus problem. And we do need to fix it, because it's not only a contaminant that's generating environmental damage, it's also a vital resource to produce food, and it is finite, and the stocks globally are decreasing. And therefore we're coming to a point where we really need to make sure that we've still got enough phosphorus to produce food in the near future. We need everybody to contribute to those solutions, and although it might feel like the farmers or the water companies are the polluters are actually us. So we are the polluters, we are consuming those resources, we are consuming that food, we are excreting those products, we are causing those fluxes to arrive in those water bodies, and therefore we all need to play a role. That may include changing the way in which we pay for environmental goods and services.